Today, I'd like to share with everyone the current state of the quantum ecosystem in Singapore, and in particular to talk about some of the activities that we have in trying to bridge the gap between fundamental science and technology and possible solutions that an end user could actually apply. Now, for those of you who are familiar with Singapore, you do know that we have been funding quantum science and technology in a concerted way for at least 15 years. We have the Center for Quantum Technologies that has actually acted to bring together, a lot of talent in the domain, and we have been extremely successful, including spinning off companies. What we would like to do is build on top of that success so that we can actually have more funding for the quantum domain, but also at the same time to begin to actually convert some of those technologies into solutions. And this is what the quantum engineering program is here to do. So the quantum engineering program is actually 5 years in duration, and we are now in phase 2. Phase 1 actually started last year, but it was extremely successful. So now the stakeholders have decided that it is time to actually expand the program. We have $96 million in funding to give out over 5 years. And I'll talk a little bit about some of the technology areas that we will focus on in the coming slides. But first, just a quick overview of the structure of the quantum engineering program. Now, the quantum engineering program is hosted by my home institution, the National University of Singapore, but it is not an NUS-focused program. We are actually here to fund activities across the entire island, wherever the ideas and the know-how is based. So we actually report to a national level steering committee, and I'm supported by several of my colleagues in the research institutions. So for example, Dimitris Angelakis helps me look at cloud computing services to see what sort of services and solutions we can get through the cloud. At the same time, we have 4 different pillars: communications and security, computing, sensors, and quantum foundry. And I have colleagues from the universities in each of these different areas. For example, in communication and security, Christian Kurtziffer and Marco Tomamico are working with me to look at what we can do for quantum key distribution deployment and also for research into the quantum internet. On quantum computing, we have Patrick Rebentros and Miklo Santa. And on quantum sensors, we have Gao Weibo, who's actually based at Nanyang Technological University. And at the quantum foundry, we have Rainer Dumke and Manas Mukherjee. So Rainer's from NTU as well, from Nanyang, whereas Manas is from NUS. And so this is a joint effort to ensure that we actually get access to all the foundry capabilities across the island. Now, the vision for the quantum engineering program phase 2 is really to deliver impact for Singapore by working on end user defined challenges. And what we do is we often will have workshops where we bring together the research community, possible investors, but also the owners of the problem sets, because they are the ones who have a pain point and they are the ones who are looking for a solution. And we are trying to identify which of the quantum technologies are ready for translation so that it can be applied. So we are actually very translation focused. The proposals that we would fund are based on challenge statements and is very use case driven. The systems that we want to see at the end, we want it to be as close to production level as possible, where there's a quantum key distribution device that's actually going to be installed in a data center, or maybe some kind of quantum sensor that's going to be used for Earth observation. So we want to see these things get out of the laboratory and get deployed out in the field. Of course, we also want to support local technology that's ready for translation and spin-off, and so that we can actually also achieve value capture for Singapore. Now, the range of activities that we're going to do under the quantum engineering program really is, first of all, to fund translation. So funding is a big part of what we do. But another very big part is we want to, sort of turbocharge our ecosystem building activity. We want to bring together the research community, government stakeholders, investors who might actually want to spin off the technology into companies, and also the owners of the problem set. But at the same time, we have a talent crunch. This is a problem that we have in Singapore. It's also the same around the world. So we want to make sure that we, promote the concept of quantum science and technology, raise the level of public awareness, so that we can encourage more young people to enter the field. Now, ecosystem building has been taking place for a while under the Center for Quantum Technologies, which was relatively successful. But now with the QEP in place, we have dedicated funding to make sure that this thing can actually grow in a nice way. Now, let's talk a little bit about the technology areas that we're going to focus on. So we focus on the traditional, quantum science and technology areas of comms and security, computing and sensors. But at the same time, we also have a quantum foundry. Now, the first three pillars, comms, computing, sensors, they are really targeted at, challenges derived by end users in industry, in government. But the quantum foundry is slightly different. The end user for the quantum foundry team is really the research team in the other three pillars. Because sometimes when you want to make scalable quantum systems, you want to begin to reduce the size of the instrumentation, you need to make chipsets. And this is what the quantum foundry team is here to do. It's here to actually leverage the set of clean room capability that we already have in Singapore, and to also capture the requirements from the principal investigators so that they can actually be brought together, and so that some of these proposals that are being carried out in the other pillars can progress much more quickly. Now, the quantum foundry is also not here just to service the local community. So if those of you who are overseas, you have some requirement or some need that you find challenging to solve, please reach out to our quantum foundry team as well for a discussion. Now, if we focus on the other three pillars that we have, I'll just give you a brief idea on the technology that we are working on. So in communications and security, we're going to build a national quantum safe network where we're going to deploy quantum key distribution. And we're also starting to look at the quantum internet, how one actually engineers the quantum internet, and what are the first tools that you have to build to see some of these protocols being tested. In quantum computing, we will leverage on our strengths in software and theory to do operations research and also to make software for simulations. At the same time, to leverage on our experimental capability in Singapore to begin to build high quality qubits so that we can actually put them into information processing devices. And for quantum sensors, we are starting to look at environment and navigation, and also applications inside the health and life science domain. Now, for the quantum engineering program, we've been supporting projects for over a year now. This was under phase 1, or QEP 1.0 as we call it. So over here, you can see a sample of the projects that are underway and being funded. We have activities in single photon detectors, both of the superconducting type and of the semiconductor type. We are investing in building new protocols for quantum key distribution, and also at the same time working on integrated devices for atomic clocks, and also for microscopy. What we want to do is build on top of the activity in quantum engineering phase 1, so that we can actually expand and bring in more people into this translational activity. Now, this will not be possible if we didn't think that we have a good foundation in quantum science and technology. And in this slide, I'm showing you the Quantum SG community, which is a collection of principal investigators across the island. As you can see, the largest group affiliation that we have is with the Center for Quantum Technologies, which has been funded for 15 years now. But through the CQT, we have been attracting more people to Singapore. And now we have colleagues at all the major research universities and research institutions in Singapore. Now, Quantum SG actually lists all the individual investigators by name and also by research areas that they are interested in. And so for those of you who would like to look for collaborators in Singapore, please actually come to the Quantum SG website. You can just Google for Quantum SG. Go to the website and have a look at the listing over there. It's like a little telephone book that you can look at if you want to look for collaborators in Singapore. Now, in the quantum SG community, if you were to break them down into experiments and theory, we have about 25 colleagues doing experimental work and about 23 colleagues doing theoretical work. And with the quantum engineering program, we hope that maybe more people who are not traditionally from the quantum domain will start to contribute to quantum science and technology as well. Because in the program that we are looking at, we not only support the building of the quantum packages, but also the enabling technology around it that's necessary to make a fully working system that you can deploy. Now, skilled manpower, as I have said, is always an issue for everyone. And so over here, you can actually look at the number of PhD positions that we have been funding over the last 15 years. We've given out funding for 84 PhD students who have graduated, and we have 61 more PhD students at CQT in the pipeline. And under the quantum engineering program, we have been supporting 5 PhD students. And we're hoping that we'll at least, be able to fund at least another 20 PhD students through the program over the next 5 years. Now, this is not a full picture because sometimes there are PhD students who are working on enabling technologies. They are not funding directly through QEP or CQT. And at the same time, we have been working with the universities to, bring in undergraduate level training. For example, at the National University of Singapore, we have a specialization in quantum science and technology so that undergraduates can actually, take part in research with the groups, with the PIs in the labs or in the research groups. And this is something that we hope to grow and expand across to all the universities in Singapore as well. Now, over the last 15 years, the biggest amount of funding for quantum has gone into the Center for Quantum Technologies. And it's done a tremendous amount of work in fundamental science and research. However, the activities of CQT are not just limited to basic upstream research. We have also been relatively successful at spinning off companies. And over here, I show you 5 of our spin-off companies from the center, which actually cover all the 3 traditional pillars of computing, communication, and sensing. And so we actually hope to continue to support these companies and also to grow the number of spin-off companies that we will see coming out through the QEP quantum engineering program. Now, the hardware companies, for example, S15, have been working very hard in making hardware that's available. For example, they make quantum key distribution devices that they've been installing in government data centers to trial the technology and to act as a showcase. They've also been building quantum random number generators that are actually ready for deployment. And so this is just an example of the kind of hardware that you can actually get from some of our spin-off companies. But also, one has to think that we also have software capability like Horizon and Entropica that's actually working on quantum computing systems as well. We have a relatively active ecosystem where we engage with government stakeholders. This is just a small snapshot of what we have at the moment. And through the QEP, we hope to actually engage a much wider set of government stakeholders. So I hope that if you check back here, in a few years' time, you'll see actually many more entities involved. Now, I'd just like to conclude my talk with a quick run through of some of the specific technologies that we're going to support in the quantum engineering program. So starting with sensing and metrology, we are going to be really supporting the integration and miniaturization of the instrumentation and control systems for atomic clocks, for ion traps, and superconducting qubits. And at the same time, we're going to support also the ruggedization of the quantum sensors that we want to deploy for Earth observation. Now, when it comes to quantum computing, we actually have a very strong collection of activities in atomic, molecular, and optical physics, with which we can make ion trap qubits. We also have new hires in the superconducting qubit domain. And so we're going to be exploring how we're going to put all of this qubit domain, qubit technology into information processing devices. And as I said, the quantum foundry is here to actually support that activity. And also not to forget that we have the strength in software and algorithms. So if we have the software side and we have the hardware side, we should be able to have some really exciting integrated computing projects coming out over the next 5 years. And finally, I just want to conclude by making a statement about communications, which in many ways is the most downstream of all the quantum technology. Now, we started out a few years ago by working with Singtel, which is one of the biggest telcos in Asia, to look at how quantum signals would be propagating over Singapore's deployed fiber network. And the results were actually very encouraging. We found that the fibers were all very high quality, that you don't always have to work with C-band like at 1.5 micron. You could also work with O-band like at 1.3 micron, simply because Singapore is actually relatively small. And almost every building can actually get a direct fiber connection to another building as well. So this is actually very promising. And we want to use this capability, use this infrastructure that's already in place to push quantum key distribution technology out to data centers. And also to try and solve all the bottlenecks that are in the way, which at the moment makes QKD less accepted by the comms community. But we hope to solve all of these problems along the way. And as I said, we're starting to look at the quantum internet as well, to look at the protocols of the quantum internet and to support the development of some of the small tools that's necessary to test this protocol. So I'd like to just end here and say that in the next 5 years, Singapore is going to build a quantum ecosystem where we're going to translate technology and convert that into solution. And if you have any interest in doing co-development with us, please look at those 3 websites that I just listed in my last slide: the Center for Quantum Technologies, Quantum SG, and of course our own quantum engineering program. Just have a look at those websites, look at the activities that we are working on in Singapore, and reach out to our community here. So with that, I'd like to end my presentation, and I'd like to thank Q2B again for inviting me to share what we're doing here on this island. And I hope to engage with everyone and see what we can build together. Thank you.